Hello and welcome to my Red Team course. We'll be going over a lot of interesting adversarial Red Team topics. I am a Red Team lead and have found that red teaming always has an interesting edge to it, as I have found it has a very creative side. I think if you're a beginner to red teaming, maybe you even want to someday be a red teamer and interested in learning some red team post-exploitation, this will be a fun course for you. Hello and welcome to this course. For a quick course overview, I'll briefly talk about the outline of the course and what type of learning you should expect from this course. First things first, I'll do my best to keep this course at a beginner's level. You'll find that this course is very hands-on. You can expect fun and quick demos that you can follow along on your own virtual machines to get a beginner's feel into how to conduct red team effects. Just a note, you'll see that the course is basically split into either briefs or demos. I'll be going over a range of different topics for the basic knowledge that a red team member should know, from basic administration commands to some common TTPs that a red teamer might use, such as enumeration, lateral movement, persistence, and more. Well, I hope you enjoy. Hello. For the Red Team Lab Setup section, we'll be going over some brief steps for setting up a simple and basic Windows domain for you to do your red team effects on. First, I'll be showing you where to download VirtualBox, Kali, and the Windows operating systems. But since this course is focused on hands-on red team TTPs, I will not be going step by step into how to install VirtualBox, Kali, or Windows. But after you install these virtual machines, I will show you a very simple and basic domain setup, including joining the computers to the domain and adding a few domain admin accounts. In this lecture, we'll be going over where to download VirtualBox, Windows, and Kali Linux. Let's do a quick search for VirtualBox. But first, just to give a quick overview of VirtualBox, VirtualBox is a free hypervisor, so that enables us to run VMs, or virtual machines. Let's go to the download link. VirtualBox has many different options based on the operating system you are using. And because I use Windows, I'm just going to use the Windows hosts option. Just for awareness, you do have the option of the popular VMware as well, but it does cost money. After you download VirtualBox, there's plenty of installation guides you could follow for installation. Next up, I'll be showing where to obtain Kali Linux. Just for a quick overview of Kali Linux, Kali Linux is a Debian-based Linux distribution with a whole array of hacker tools pre-installed. Go to the download link from kali.org and you'll notice multiple options based on the architecture and type of install. I recommend the Kali 64-bit installer ISO. Just be aware, it is a 3.6 GB file, and you'll probably want to have at least 30 GB or more for the virtual machine, so make sure you have plenty of space on your computer, especially for the Windows VMs as well. Another option is to download a pre-configured VM by Offensive Security, which in this case, I would recommend the 64-bit Kali VM as well. And right here, you have the VMware option if you prefer to use VMware Workstation instead of VirtualBox. But then further down, you can see a VirtualBox VM as well. Next up, I'll show you an option for getting a Windows 10 virtual machine. Microsoft offers free Windows 10 virtual machines from the developer.microsoft.com website. So just be aware though that these are evaluation versions, and I've noticed at times they have restarted on me. Notice that there's a VMware and VirtualBox option to download from. Another option will be to buy a license of Windows 10 and then download and install from the ISO. Now I'll go over an option of downloading Windows Server. Right here is an evaluation version of Windows Server 2019 from Microsoft.com. There's an ISO version that you could download, and the evaluation lasts for 180 days. Also, if you scroll down, you can see plenty of other options as well, such as Windows Server 2012 R2. For the demos in the course, I'll be using Windows Server 2012 R2 as the domain controller. In this video, you can follow along if you want to create a simple domain so we could have a small environment you could practice your red team effects on. For this environment, we'll be setting up a Windows Server VM, which will be the domain controller for a domain in which our Windows client will be joined to. So the first thing we will want to do on a newly created Windows server, which will be our domain controller, is to set up our IP address statically. This will ensure the IP never changes in case there is a DHCP server on the local network that will lease IPs randomly every so often, which would effectively change our domain controller IP, which isn't good if your clients are trying to connect to the domain with the wrong IP for the domain controller. So take a quick glance at how I manually set up the IP address to 192.168.122.129, and we'll close out and next configure the Windows Server to a domain controller. So just X out of everything until we get back to the Server Manager, which is a simple dashboard that has a lot of useful links for quick access to configuring the Windows Server. After clicking on Configure this local server, click on the computer name as we will change it to a domain controller name that is more suitable. I chose the name FunDC01, DC being short for domain controller, and restart the computer to take on the effect. The reason I chose the name FunDC01 was because it's a simple way for me to have the domain, which is fun, and to show that it's a domain controller. On the Server Manager, click on Add Roles and Features so we can start the setup of the domain controller. Click Next and then ensure you have role-based or feature-based installation selected since we aren't doing a VDI. Click Next on this page. Select Active Directory Domain Services so we can easily add and manage users on the domain later on. And scrolling through, you can see a lot of other interesting roles that you could add for the server. Next up, you can see a list of features that could be installed on the server. But for a simple setup, we can ignore this. Now let's install the Active Directory role we selected. Click on Promote this server to a domain controller, and next select Add a new forest, giving the root domain name fun.com. We use fun as our domain, and I just use .com, but others may use .local, or really whatever you want. It doesn't really matter for our local domain setup that won't even be registered on the internet. Next, put in a DSRM or Directory Services Restore Mode password for offline emergency maintenance, and just click Next on the Specify Delegations option. For the next few options, just click Next as well. It looks like there's an issue, and this issue will happen if the local administrator account on the Windows system does not have a password. To fix this, we can add a password simply by first opening up an administrator command prompt. Run netuser to see the local admins that are currently on the server. And typically, the main local admin of concern is normally just named administrator. So run the following netuser command to add or change the password of the administrator account. And now that the administrator account has a password, click Previous and next to attempt the installation again. Be aware that a lot of these installation steps do take quite a bit of time, depending on the hardware you may have. So don't be alarmed if it takes quite a while. Setting up a domain controller could normally be a day or more of a task for systems administrators based on the hardware they are working with and the type of domain that they are required to set up. And many restarts are also a very typical part of this process. Once the server is restarted, log into the local administrator account, as we will be setting up some user accounts through Active Directory. Wait a little for the server desktop to load up, and then search and open up Active Directory User and Computers, as this will be where we can manage user accounts. In here, you could get a list of information of our fun.com domain. For example, you could get a list of computers connected to the domain and also a list of the domain controllers. Click the Users folder and you'll get a list of users and groups in the domain. To create a user, you can right-click and click New and User. For our first user creation, we'll create a user named John Doe. And after filling in the first and last name, we could then fill in the user logon name, which I'll just do in the format firstname.lastname. Then we'll write in a password that's complex enough for the Windows domain. After you write in the password, uncheck user must change password at next logon, so we don't have to change it next time we log in. And also make sure password never expires is checked. And now that we have the user created, let's right-click on it and go to Properties so we can change the group the user is in. Click on the Account tab and you'll see some account options and also the option to unlock the account if it is ever locked. And now to change the group the member is in, go to the Member Of tab. And here you'll currently see that the user John Doe is in the domain users group. So next what we'll do is we'll create a domain admin that will be in the domain admins group. We'll right-click, click on New, and then User. I'll name the first domain admin Peter Pan with the same username format of first.lastname, peter.pan. I'm just naming it this way so I can easily distinguish the admins and users myself. And again, we'll type in a password that's complex enough for the domain, and then also make sure user must change password at next logon is unchecked, and then also password never expires. And after creating the account, right-click on it and go to Properties. And once the properties are open, go to the Member Of tab, and you'll notice that the member is only in the domain users group. So click on Add so we could add him to the domain admins group. Type in domain admins, click Check Names so you could confirm that the group is there, and then click OK so we could add him to the domain admins group. Alright, next we'll create a domain user and a domain admin again. But this time just right-click copy on a user we already created. And since I right-click copied on Peter Pan, that means this user I create should be a domain admin. So I filled in the name Jason Bourne and user logon name jason.bourne. And again, type in a complex password because of the domain group policy, which you could easily change. And then after creating the user account, we'll right-click Properties, and then go to Member Of to see what groups he's in, which is already domain admins and domain users. Now we'll create a normal domain user account by right-clicking on John Doe, and then copy. And then for this account, I'll just call it Jane Doe, and then of course the same first.last name format for username. And again, a complex password, which I've been using the same password for each account just for this red team environment. Then right-click Properties and go to the Member Of tab. And notice he is only in the domain users group since we copied a user that was only in the domain users group. So now that we have enough users for our red team domain, let's go over an example of how to add a Windows client to the domain. So while you're on your Windows client VM, which could either be Windows 7, Windows 10, or wherever you want, the first thing we want to do is to set the IP address of the computer. So I'm just doing this manually because I do not have a DHCP server in my local network. So set the IP address to an IP address that's not currently being used. The subnet mask needs to be the same subnet mask that was used for the domain controller. And then we can set the preferred DNS server to the IP of the domain controller. That way the client could resolve fun.com. And then now that we have an IP address on the same network as the domain controller, we could then join the computer to the domain. To join the Windows client to the domain, go to System Properties, and then click on Change, which will give you the option to join a domain. I set a new computer name for the client called Win10User, and just type in fun.com in the domain field, and OK to bring up a prompt to join with credentials, which in this case, I'll be joining with the peter.pan domain admin we created earlier. And then after successfully joining the domain, you'll have to restart the computer. So then after the computer has successfully restarted, you'll want to click on Other User and then type in the domain admin peter.pan's credentials to log into the domain fun. And then since this is the first time that this account is logging in to the domain on this client, it might take a little while longer than a normal login to load up. So then, once it loads up, the first thing I'll do is open up a command prompt and type who am I just to confirm that I am peter.pan. And then of course netuser peter.pan/domain just to confirm I am a domain admin. And then, because this is a beginner's course, you can follow along to disable the Windows Firewall. In Windows Firewall settings, click Turn Windows Firewall on or off. And then for domain network settings, private network settings, and public network settings, we'll just click Turn off Windows Firewall. Also turn off Windows Firewall on the Windows client as well. And then next, we'll just disable the Windows Defender so we don't have to be worried about spending time obfuscating our payload to evade the antivirus. So what is red teaming? In this lecture, I'll go over what red teaming Windows Active Directory domains is. In the most generic sense, it's a cyber assessment of a network. But then how is it any different from penetration testing? It can be confusing, but there is a difference. As what's most commonly known, penetration testing is basically a hacking assessment of a target application, system, or network. And it can widely vary and range from a simple vulnerability scan to a methodological scanning to hacking to just trying to hack in any way possible. Then, from what vulnerabilities and security misconfigurations that were found and or tested to see if the hacker could get in, a report is written up and sent to the customer, who will then use it to figure out how to make their security stronger. Red teaming takes the methodological approach to another level. They aren't focused on finding all the vulnerabilities in the network. They may focus or narrow their approach and then may spend more of the time working on post-exploitation effects, such as persistence, evasion, extraction, and simulating an adversary with an objective in mind. Their goal also is normally to do it all under the radar, like a ninja. Typically, a red team may be there not only to assess the IT infrastructure security implementation, but also the people and processes that are in the organization as well. People could range from normal users on the network to the system administrators and the network defenders. For example, as a red team member, you could potentially figure out how to use the real-time users on the network to your advantage, and also at the same time, figure out how to stay stealthy and not get caught by real-time defenders looking for any actions that are seemingly malicious on the network. And in turn, The actions that are done can improve processes in the organization. For example, maybe the network defenders learn new ways to detect advanced tactics from an adversarial source. Or it could maybe be the organization can add new alternatives to their training of operators when something goes wrong. When it comes down to red teaming, there's some terminology that you may run into every so often. TTPs, or Tactics, Techniques, and Procedures, are simplified ways for red teams to label and mimic actions and effects of real-world adversaries. Going from tactic to technique, then procedure, is just a way to go from the highest level broad description down to the lowest level detailed descriptions or steps. Adversary, which is a term used to represent the bad guy, ranging from an individual, group, organization, or government that conducts malicious activities. Red teams like to use similar effects that real-world bad actor groups or adversaries may use. And that's a good benefit of red teams, as they can work to replicate actual adversary TTPs to test the organization's strength against real-world threats. Tradecraft for red teams pretty much refers to the skilled techniques, methods, and technologies used for your operations. OPSEC is a term that means operational security, which is a process that identifies critical information to determine if friendly actions can be observed by enemy intelligence. So to a red team member, that term basically just means how stealthy you are and ensuring you aren't leaving any tracks or traces behind for the network defenders to find or catch. The last thing you want is for a network defender to find a left-behind artifact that, when reversed, shows valuable information to uncover how your TTPs work. To understand red teaming, it is good to know blue teams and the difference between red and blue teams. Blue teams are a group of security professionals that focus on the security of the organization's networks and systems. They are proactive defenders for the company that focus on the detection and prevention of cyber adversarial attacks. They may spend time looking at data logs, such as through firewall or IDS or IPS logs. Also, they may review system logs on hosts and network logs like PCAP with Wireshark. They may cover identifying and mitigating any found vulnerabilities, reviewing or implementing security rules and policies, and more. They are basically known as network defenders, watching the network and systems for anything unusual. When it comes to the differences between red teams and blue teams, you can think of them as sort of polar opposites. Blue is the defender and red is the attacker. Since blue teams are seen as network defenders that are looking to detect and prevent adversarial cyber attacks, red teams are taking the approach of replicating an adversary. Since blue teams are focused on the security and protection of the organization, red teams are focused on looking for weaknesses in the systems, processes, and people of the organization. Red teams focus on bypassing network defenses, working on getting past or around security measures, and blue teams. This in turn provides an emulated threat for blue team training and an adversarial approach to cyber assessment to show weaknesses, which helps build up the security posture of the organization. MITRE ATT&CK is a globally accessible knowledge base of adversarial tactics and techniques based on real-world observations. It's a nice place to get a quick overview of some common TTPs, or tactics, techniques, and procedures that a red teamer may use. TTPs in the security community is a way of analyzing an adversary's operation to profile the threat actor. Let's take a closer look at the MITRE ATT&CK. The easy way to access MITRE ATT&CK is to search MITRE and go to this link right here. Scrolling down, you can see a good list of many tactics, techniques, and procedures that were conducted by real-world adversaries. The tactics, or tactical objectives, are shown at the top of these 12 columns, representing the reason behind what the adversary is trying to accomplish. For each tactic, there is a list of techniques, which are the ways that the adversary will achieve the tactic. Let's click a technique. And looking down here, we can see a list of specific procedures of past attacks from real-world adversaries. For example, if we click a procedure, we can get detailed information on how the adversary would conduct the technique to achieve the tactical objective. In this lecture, I'll go over a brief overview of the command prompt, PowerShell, WMIC, schedule tasks, and the Service Control Manager. CMD, which is Windows Command Processor or Command Prompt, is a command line interpreter for Windows that executes commands. It is a simple way for the user to interact with the system through commands, commonly used for network management, file management, processor management, and more. PowerShell is a task automation and configuration management framework from Microsoft, consisting of a command line shell and associated scripting language. PowerShell is built on top of the .NET Common Language Runtime, or CLR, and accepts and returns .NET objects, meaning it enables the capability to interact with Windows objects. Its wider variety of commands you can use are in the form of what's called commandlets, enabling easier scripting and automation, and adds more power to your toolkit for Windows management capabilities. Here is a side-by-side comparison of PowerShell and Command Prompt. You can see what the PowerShell window looks like on the left and the Command Prompt on the right. Although PowerShell can do dir as well, unlike Command Prompt, it can also get the directory listing with ls, or even the commandlet get child item, and there are more ways in PowerShell to do alternatives of specific capabilities as well. WMIC stands for Windows Management Instrumentation Command Line. It enables WMI operations through a Windows shell. WMIC is a great way for being able to have powerful control over local and remote systems, enabling an administrator with the power to do things such as start-stop processes, run scripts, query system information such as network and device settings, and configure settings on the system. Schedule tasks manages scheduled tasks on the target system. Schedule tasks can be used for creating, deleting, querying, changing, running, and ending scheduled tasks on the local or remote system. Scheduled tasks is capable of running executables and scripts on the system during a determined time that you choose. SCM is a Service Control Manager, which you can access with sc.exe. SC is a command line program you can use to communicate with the Service Control Manager and services. Service Control Manager is capable of creating, deleting, querying, changing, running, and ending scheduled tasks on the local or remote system. We may use SCM or scheduled tasks to our advantage by running malicious payloads, and to top it off, the capability to execute at the system level privileges. C2 post-exploitation frameworks are very important for red teams, and this lecture will briefly explain why. C2 stands for Command and Control, and based on MITRE ATT&CK, it is when the adversary is trying to communicate with a compromised system to control them. Command and Control consists of techniques that adversaries may use to communicate with systems under their control within a victim network. Basically, in terms relatable to a hacker, Command and Control means the capability of being able to execute your TTPs when you need. So in another way, it's like having malware on the target computer to execute instructions when you need it to, like exfiltrate data, keylog the target user's keystrokes, capture the desktop, command execution, and more. For good C2, there's an importance to ensure access is maintained, with stable and reliable connectivity to ensure the tactics that the operator desires to conduct happens. Now, a C2 post-exploitation framework is software that's designed for post-exploitation. There's many custom-made post-exploitation commands that come with the C2 framework you use, which automates tactics for the red team operator, such as lateral movement and data exfil. Just be aware that most of the time, the basic automated commands could be a simplified version of the tactic that is easily catchable by a blue team or IDS. Also, many C2 frameworks typically support teamwork and collaboration, providing ways for the multiple users to work together on the operation. Another feature many C2 frameworks provide is the option for customized C2 profiles, which typically can modify things such as the malware or implants network and host-based behavior. This provides the capability to help blend into the target environment, mimicking what the common traffic looks like. If you want a good list of the current C2 options out there, the c2matrix.com has a good list showing software and agent code, user interface information for whether it's web-based, a customized graphical user interface, or command line interface, the channels such as TCP, HTTP, and SMB, agent support like Windows, Linux, Mac OS, and capabilities. In this lecture, I'll go over the common red team tools Powersploit, Bloodhound, Mimikatz, and Impacket. Powersploit is open source and made up of a whole array of PowerShell modules used to perform all sorts of TTPs, or tactics, techniques, and procedures ranging through all phases of the penetration testing process. These include ways for Windows domain enumeration, such as with one of Powersploit's tools, PowerView, privilege escalation on Windows hosts, like with a popular tool PowerUp, which is able to scan for misconfigurations that can enable upgrading to elevated privileges, persistence, to enable maintained access to the target even through mitigating factors such as machine reboots, and bypassing antiviruses so your payload does not get caught, although all these are now outdated. Bloodhound is a simple way for red team members to get a nice picture of the Active Directory Windows domain they are enumerating. You basically run the Bloodhound script, that's called an ingester, to automatically enumerate information about the Active Directory environment. Then you load the file output into a Neo4j database, which loads a nice graphical user interface and connected layout of hosts and users. There are many nice things that you can filter with the output from Bloodhound, such as finding the hidden and unintended relationships within the domain environment, trusts between domains that can be leveraged for escalated access, narrowing down which users have access to most systems, which users are logged in where, and showing a nice path of going from a domain user to domain admin. Mimikatz is a tool that's most well known for dumping hashes, although many people may not know that there's a lot more functionality to this tool. Capabilities include a variety of useful features, including, of course, extracting hashes from the host you are on, then extracting clear text log and passwords in memory, extracting Kerberos tickets, using an extracted hash to then pass the hash for access to another system. And another capability of Mimikatz is the ability to create golden tickets and use the ticket for remote access. In fact, there is a lecture under persistence where I go over a demo of how to use Mimikatz to create a golden ticket and use it to access the domain controller with the domain user account. Of course, that's not all. I recommend everyone to go and research about all the capabilities of Mimikatz and have fun testing out all the functionality. Impacket is a collection of Python classes for working with network protocols. Impacket is focused on providing low-level programmatic access to the packets, and for some protocols, the protocol implementation itself. Impacket is a collection of different capabilities for network protocols, enabling penetration testing and red teaming. except instead of being PowerShell written tools like PowerSploit, it is a collection of tools of Python classes. These Python tools each have their own capabilities, ranging from remote execution Python tools, such as ones that replicate psexec, Kerberos tools, such as the Python tool getUserSPNs, which is useful for the Kerberosing attack, credential extractions for Mimikatz capabilities, SMB man-in-the-middle attacks, and many more. It might be good for you if you went through each of these Python tools available with Impacket and tested each one out to get a good feel of the capabilities available. Plus, you could always go a step further and learn from these examples to create your own custom tools that uses the Impacket library. I'll show a basic example of how to set up a payload and listener on your Kali system. Then get it running on the target computer so that way you could follow along in the later TTP lectures. First, before I run Metasploit, I'll make sure the database PostgreSQL is running. This way we can speed up our module searches and even gives the capability of saving search results. After PostgreSQL is started up, I'll type MSF console to start up the command line interface to interact with the Metasploit framework, which you'll see as a collection of exploits, auxiliary, and post-exploitation modules, and payloads and encoders. Now with MSF console started up, I'll type use multi-handler to set up a handler that will listen on a port for the payload calling back to it. The handler will handle the exploit for us. In the case of a Windows x64 Meterpreter reverse TCP payload, or a staged reverse TCP Meterpreter payload, it will listen on a port, receive a connection, and generate a payload that will be sent to the target who will run it. There's a few options to set, but I'll just set the L host, which for a reverse TCP would be the Kali host. This would be opposite, aka the target IP, if it was a bind TCP payload. I'll be keeping the L port to 4444, but you may want a less obvious choice. I'll run IPA to get my Kali Linux's IP address and set the L host to the current host with the following command. Another option on the handler listening for a reverse payload would be to set the L host to 0.0.0.0 to listen on all Kali interfaces on the specified port. Set exit on session to false to make sure the handler job stays running and does not stop after the first session is established. Then run -J to run the job in the background. Type jobs to see the current jobs running. Type netstat to find port 4444 is listening on the specified interface IP address from Metasploit, which is written in Ruby. Open to anyone to connect to. Now to create the malicious executable that will run on the target to run the payload, use MSF Venom, which will be able to create the payload shellcode. And with this following MSF Venom command, I am setting the payload to the same as the handler. The L host needs to be set to the Kali Linux's IP address, and the L port needs to be the port we opened up listening for the connection. And set the file type to exe for the windows.exe format so it can run on the Windows target, and output to a file called test.exe. Outside of a test environment, you may want to come up with a more sneaky name. With the executable created, host it with the following case-sensitive Python simple HTTP server command. Listening on port 80, which you could use in other if 80 is taken. Looking at netstat again, port 80 is listening from the Python listener and open to all addresses. Next, go to the Windows virtual machine and go to the Kali machine's IP address to download the file. With the file downloaded, run it as administrator for more access rights. Returning back to the Kali Linux virtual machine, it shows a session pop up. You can enter a session by typing the following command sessions with a parameter I to specify the session number, and in this case, it is session 1. Then with the interpreter session, type get_uid to see what user you currently are. I'll be going over some basic Linux commands in Kali Linux. First, I'll show a quick option to show all the commands possible in your Kali Linux command line. As shown, I'll just type the letter A and then press tab a few times. And here you go, we can see all the commands starting with the letter A. I'll do it one more time with the letter B. And then we can see all the commands shown, starting with the letter B. We'll type clear, then enter. So that way we could clear the terminal. We use the command cd, so that way we could change directory. We can use ls, so that way we could list the directory contents. But if you notice, there's nothing in this directory. So we'll use the make directory command to make a directory called test. So now you'll see that when we do ls now, we'll see the directory test pop up. We can change directory to the directory test, and notice that we are in /public/test now. We'll ls again, and see there's nothing in the directory test that we just created. Let's create a simple file, test.txt, by using the command echo to output the text line hello into test.txt. We'll use the command ls again to see that test.txt is now created. Or we could use ls-la to get more detailed information. We're also able to use the command cat to display contents of test.txt. It looks like the contents hello is inside test.txt. Next command is ifconfig, which shows our Kali's network interface devices. Another newer alternative is IPA. We use IPR to show the routes, or netstat-rn to show the routes as well. If you're ever having issues with networking, you could always use the service networking. So we could always type service network restart to restart our networking devices. Of course, if you're still having issues, there's two other options you could do to restart your networking devices. First one is if you want to restart eth0 specifically, you could type ifconfig eth0 down, and then check with ifconfig to see if it's actually down. And then ifconfig eth0 up to bring the interface back up. Another option to restart your networking device is to use /etc/init.d/networking restart. To remove files, we can use the rm command. As shown, I'll use rm space test.txt to remove the test.txt file, and then you could use ls to confirm that it is gone. Let me just create another test file really quick. and then I'll do cd ... to go back a directory. I'll use ls-r to recursively list directory contents. As shown, we can see the directory test, and it'll also go further and see what's in the directory test, which is test2.txt. Now to help out, to find out more information about each command you run, you can always type the command with 2 hyphens and help. And now it will show all the parameters possible with the ls command. Another option other than help is to use man. It brings up the manual for ls, which you could scroll through and get more information about all the parameters. So we have covered some basic and simple Linux commands and also ways to find out more information about each command. Since this course focuses on Windows targets, we'll be spending most of our time with Windows commands. In this lecture, we'll be going over some very simple and basic Windows commands to get you a comfortable head start with a Windows command line shell. First command I'll type is hostname. That'll show the name of the computer that we are on. We'll type CLS for clear screen. And then next, we'll type ping to our loopback interface on 127.0.0.1. And what ping does is it sends ICMP packets to another target to check if it's alive. Next, we'll send a ping with only 2 packets with a parameter -n2. This only sends 2 packets to the target. We'll clear screen again. And then next, we'll do ipconfig/all, which will show information for the interfaces on our Windows host. Alright, let's take a look at fun.com. Maybe we could nslookup it. nslookup fun.com and see it comes back with the address of the domain controller. Next we'll type netstat-ano, and this will show all the computer's connections and ports listening and associated with services by the PID or process ID. Next, we will type route print to show the route information for this host. It will show the network destination, the net mask, and the gateway that the information will go through for that route, and also the interface and metric, which shows the computer's routing decisions for priority of the packets it sends. Next we'll type arp-a to show the physical address to IP relationship. The 132 host has a physical address, also known as the MAC address. The ARP command could help to show what systems may be on the network. So let's try to ping the 132 target to see if it is up. One thing that always helps is to check with /?, because it will show a list of parameters that the command can do. Let's take a look at ping /?. When you have time, take a quick look at all the parameters you could do with ping, and also take a look at parameter n, which we have used before, which means the number of echo requests to send. One very useful command I like to use to troubleshoot some post-exploitation issues is the nethelp command. With nethelp message 53, it shows the network path was not found. Don't forget to do nethelp message and that number to show what the error is. Now I'll go over a few other simple commands that are good to know. First is the dir command, which lists the directory contents of the current directory you are in. Next is the cd command. To change the directory, we'll do cd ... to go back a directory. Let's do the directory listing again to list the contents of the current directory. And let's change directory back to the desktop. Let's use the command echo to echo the word hello into a new test.txt text file. Let's do a directory listing to see that the new text file is created, and we'll use that type command to see the contents of the new file that we created. I'll be doing a quick overview of Windows Account Management in command line, where I'll go over a few basic commands that's important for a Red Team member to know. Just to confirm what account I'm using, let's check who am I. It looks like my account I'm in right now is Peter Pan. I can check if he is a domain admin first by doing net user peterpan/domain. And you can see the user account Peter Pan is a domain admin. This is important because for most of your commands you'll be doing as a Red Team member, you'll most likely need to have or escalate privileges to a domain admin account. Otherwise, you will not have the permissions on the network to do account management. So next, we'll check what other groups there are. So I'll do a net group/domain to check all the groups on the domain. It shows we have domain admins and domain users. So one option I can do is also check what users are on the domain. So I could type net users/domain. This command provides a list of users there are on the domain. But the problem is we don't know who is a domain admin and who is a domain user. So let's find out who is a domain admin and who is a domain user by typing net group/domain, and let's check domain admins. Now let me show you an example of it not working. So if I type net group domain admins, you'll see that this can only be used on a Windows domain controller. So make sure you don't forget the /domain. Next, we can check who the domain users are by doing net group domain users/domain. And it looks like pretty much everyone is in the domain users group. Now let's say I want to upgrade a domain user to a domain admin. It seems like administrator, Edward Scissorhands, Jason Bourne, and Peter Pan are domain admins. But for example, Alex Johnson is not a domain admin. So to upgrade him to a domain admin, I just have to type net group domain admins alex.johnson/add and /domain. You'll see it was successful. But just to confirm, I'll check to see if he is a domain admin. Net user alex.johnson domain. We could see he is now in the domain admins group. Let's remove him. But let's say you didn't know the parameter to remove him. We'll type net group/?. Now it looks like there is a /delete. And remember, we used /add to add him to domain admins. So let's type net group domain admins alex.johnson delete domain. Now let's check to see if he's still a domain admin. And here it shows he is only a domain user now. Next, let's say we run into a weird issue where a user account is not active. For example, let's do net user edward.scissorhands/domain. And we'll see his account is not active, so we can't use him. But how do we activate him? We could use the command net user edward.scissorhands active yes/domain and we'll check his account again, and we'll see it is now active. Also, instead of net user or net group, there is another option with WYMIC. We can use WYMIC group list brief, and it will show us the groups for the domain. And also, WYMIC user account list brief, and it will show us the users on the domain. In this video, we'll be going over domain enumeration commands. When you're on a red team on a Windows network domain, it is important to know how to get information when you can, because situations in the environment may always be changing, such as a user logging in. We'll go over a few basic Windows enumeration commands that may be good to know while doing red teaming, such as getting the current domain's information, getting the current domain controller's information, grabbing the domain policy, listing the host names in the domain, and finally finding which users are logged in on a target domain system. There's two things to note here. One is I am in Cobalt Strike, which you could use your own C2 framework. The second thing is that the commands I'm going to be running in Cobalt Strike require PowerView, so I did import PowerView before running these commands. First, I'll be using PowerView's getNetDomain command, which will show me the current domain information. Right here, I'm in the domain fun.com. Next, I'll run the command getNetDomainController, which will show me the current domain controller information. Just take quick note that the reason I'm running PowerShell in front of each command is because it's required by Cobalt Strike so that I would open up a PowerShell shell so that way it could run a PowerShell command. Looks like we can see the information that we are in the domain fun.com and that the domain controller's IP address is 192.168.122.129. Take note the different information you get from each command. Next, we'll check the domain policy. Here we see the command getDomainPolicy, which will get the domain policy for the domain we are on. Next, we'll use the command getNetComputer to see what the host names are of the computers connected on the domain. Let's take this a step further and see what users are logged on all the computers that we found on the domain. I'll pipe the command getNetLoggedOn into getNetComputer so I can check the logged on user accounts for each computer found from the command getNetComputer. Now we have a whole list of all the users logged on each of the computers that are on the domain. The user account administrator is currently logged on the domain controller. And after scrolling down some, you can see the user account Peter Pan is logged onto the computer Win10User1. The user Jane Doe is logged into Win10User2. And also, Jason Bourne is logged into Win10User2. Next, I'll show an option if you want to just scan a specific target for users that are logged in. I'll just take note, as you can see up here, that I'm on the hostname Win10User1. For this, I'll target the hostname Win10User2 and check what users are logged into that system with the command PowerShell getNetLoggedOn and computer name with a computer name Win10User2. Take notice that it narrows it down to Jane Doe and Jason Bourne that are logged into Win10User2. Now I can show you a potential way how to do some of these without PowerView. Since these don't require PowerView, you could easily follow along on your own Windows VM on a domain. First, I'll show you two ways you could potentially get the domain you are on. First one is ipconfig/all. Looking near the top, we could see fun.com is under primary DNS suffix. Now let's use wimic nt domain to get the domain controller information and the domain name. And now we got the information 192.168.122.129 for domain fun. An alternative to get the domain policy could potentially be gpresult. And we'll do /h gpreport.html, which will be the output file, and we'll open it up and we can see a list of the domain policy. Next is an alternative to PowerView's GetNet computer. We received the DC and the two other hosts on the domain. Finally, we'll show another way other than GetNet logged on to find the users that are logged into another computer. I'll just double check the host I'm on, and let's target the other host, Win10User2. For this, we'll use qwinsta so we can check what users are logged into the other computer, Win10User2. And it looks like Jane Doe and Jason Bourne are logged into that computer right now. In this lecture, we're going to be going over some simple and basic host enumeration Windows commands. As a Red Team member, it is important to know basic host enumeration commands to get a better understanding of the target system you are on. These commands include getting you basic information on the system, its patches, local user accounts created on the system, a list of running and startup services, information on services listening on ports, and locations of running processes, showing installed programs, and searching the file system. First, we'll do a simple command to show system and patch information. All you have to do is type system info. And as you can see, we could get a lot of information on the system, such as the host name, the operating system, which you could see as Windows 10 Enterprise 2016, the operating system version, the architecture type, which is x64 in our case, the domain, and also if there's any hotfixes or patches. In our case, we don't have any. Next, let's get some more information on the current user we are on the host. We can get username and group information of the current user we are on the host by the command whoami/all, which may be useful for a golden ticket in the future, and also group information for which groups the user is in, and also privileges of the user as well. Next, we'll find out which local admins are on the host with the command net local group administrators. It looks like administrator is in the local group administrators, which is very normal. But it's always good to run this command when you're on the host so you could always check if there are other local administrators that we could use. Next, we'll show how to list running and startup services. First command will be wimic service with a case where state equals running only. And then we'll get caption, name, and start mode and state. And then up at top, we have a caption, name, and start mode and state. Taking a look here, the services are currently running. The next command we'll run will show startup services. We'll do wimic, startup, and we'll get caption and the command. This reveals that we have 3 startup services, and it shows what command it'll run at the beginning. Next, we'll go over running port and process information. For port information, we'll run netstat-anob, but it seems like we don't have the required privileges, so we'll just do this in an administrator command prompt. -ano would work in our normal command prompt, but it's the B parameter that doesn't work, because that's the one that requires the administrative command prompt. But I want to run it for a reason. You'll see it shows the executable name. And after running the command, it comes back with a list of ports open and listening on the host. We're on under local address, listening out to what's under foreign address, the state it's in, which these are under listening, and the PID, which is the process ID, or basically the process that opened this port. And under it, you can see the name of the executable that's associated with the PID that's listening on that port. Going down a little, let's take a closer look at spool SV, which is associated with PID 1880, and it's listening on port 49667, which is open to any address. But what if we wanted to find out where this executable is on the file system? For this, we could type wimic process, where name equals spool SV, and we'll get the name, process ID, and the executable path. Then, under executable path, we can see where spool SV is located on the file system, and the associated process ID it's running on, and the name of the process. And here's an alternative option with GWMI in a PowerShell command prompt to find the same information. Next is a way to show installed applications or programs on the file system. To do this, we'll type wimic product and we'll get name and version. And another alternative is with this PowerShell command. We'll use get item property. Then after running that, it looks like we have Wireshark installed on the system. Now we'll go over how to search for files on the file system. First, I'll use the cd command, which changes directory, and we'll change it to Peter Pan's directory under C, users, Peter Pan. We will use the dir command, but instead of just dir, we will use dir with a /s to recursively search, and then we'll look for any file with a text flag in it. And it looks like we found flag.txt under C users Peter Pan documents. But what if we wanted to search for hidden files? Let's check under dir/?. If you take a look here, there's a /a and attributes. And then down here we have a /a, and then under there's attribute h for hidden files. Let's do dir/a:/h for hidden files, and then we'll do /s, and then search for any file name with the text flag in it. Then under C Users Peter Pan Documents, we found a hidden file, hiddenflag.txt. For this lecture, I'll be going over how to copy, download, and upload a file to the target system we're on, and also a remote target as well. First, let's go into the session that we have established from before. Then I'll run the following command to check we are still Peter Pan, which is the domain admin. And before we go into some manual methods, I'll just show you some methods of doing copy, download, and upload through Meterpreter. In this list, it shows Meterpreter has the options to upload, copy, and download. And any C2 framework you use will probably have these commands as well, built in, such as Cobalt Strike, Covenant, or any other C2 framework you may use. So let's check which directory we're in right now. And then let's see if we could download this file with the Meterpreter download command. Now just to confirm on this other tab, it looks like we now have the file on our local attacker machine. Next, let's see if we could upload this file, evil.txt, to the target system that we're on. Type lpwd to check which directory we're in on our Kali system, lls to see the files on our Kali system in that documents folder, which you could see we have evil.txt in there. And let's upload that file to the target. Now let's type ls to see that under Peter Pan/downloads, we have the evil text file there. Next, let's copy a file to another directory. Let's check the test directory. It looks like nothing is in there. So let's go back a directory and let's copy the evil text file to the directory test. I'll also add the name of the file at the destination. Check the directory and see it's there. So let's remove the evil text files. And let's remove the test file off of our Kali Linux system. Now if you're using a C2 framework that doesn't have these functionalities, or maybe you need to do this without a C2 framework, we could do it the manual method from a Windows shell. To do this, let's go into a command prompt shell. First, I'll show you how to copy a file over to another directory. It's very simple. Just use the copy command test.txt and let's copy it to the folder test. Let's check to see if it's there. I'll delete it with the following command. Now let's upload a file. To do this, I'll use Impacket, so I'll do Impacket SMB server. I'll make my share called test, and I'll use the current Kali directory I'm in. So I'll upload evil.txt to the system we're on by just using the copy command to the target attacker host's IP address that's hosting the SMB share. I'll quickly check the IP address of the Kali machine and see it's the 128 address. As shown from before, our SMB share is called test. And then I'll take evil.txt and I'll put it in the current directory I'm in on the Windows target. Now we have evil.txt on the Windows machine we're on. Next, I'll copy a file over from the machine we're on to our Kali system. And that's a simple copy command as well. So let's copy test.txt over to the 192.168.122.128 to our shared test by basically having the remote host as the destination. And taking a look here, it's confirmed that the test.txt was copied over. Next, what if we want to copy a file to the remote target system? Type in the following command to another Windows host, which I'll set as the 132 target. And it states that a file copied over. I'll do a remote dir command to check and confirm it was copied over. Listing contents of the directory, it looks like it was successfully copied. Now, what if we were browsing around the directories and found a file we were interested in on the remote target? Such as this directory under Jane Doe's documents. We could see this file, hello.txt, and we might be interested in collecting it. We could just copy it over to our Kali share test with the following command. Now let's check our Kali machine, and we'll see we have hello.txt copied over. And then, of course, if we wanted to upload a file to that system, we'll just remote copy our test.exe from our Kali machine 128 under the test directory. And we'll copy it over to the 132 target, to the test folder under Jane Doe's documents. And then if we check that directory, we have test.exe, our payload, on the remote system. In this lecture, we'll be going over how to remotely and locally kill a process. During a red team operation, this may be important to know. One example is if you run into an issue where you need to delete an executable, but you can't delete it because the process is running. Another example is if your malicious process is running on a target computer and you don't have a session to it anymore, so you could remotely kill the process and then remotely delete it afterwards to clear your tracks. First, let's locally kill the calculator process on this computer. First, searching what the PID or process ID is of the process, we'll use task list. And looking here, win32calc.exe is PID 2736. I'll copy that, and let's take a look at task kill. Task kill takes the PID of the process we want to specify to be terminated. So let's do task kill 2736 for the process ID of calc.exe. It terminated calc.exe on the local system. Now let's do this to the remote 132 target. I'll first check how I can do a remote task kill with a /?. It looks like to remotely target the system, we need to use the parameter s, which specifies a remote system to connect to. So let's do task list /s 192.168.122.132, and right here on the target 132 system, we have win32calc.exe as PID 1288. So I'll copy this, and let's take a look at task kill again. Again, it looks like if we want to target a remote system, we have to use /s as well. Let's do task kill /s 192.168.122.132 and then /PID 1288 because that's the process ID of the calculator process on the remote system. And take a look here, the calculator process was terminated. Now I'll show you an alternative way to kill a process remotely, which we'll use Wimic for this. So let's run calculator again. We'll check what the process ID for this new calculator process is. Notice the process ID is now 296. I'll copy this. And we'll type wimic/node, the target 132 address, and we'll do process where the process ID is equal to 296. And we'll call to terminate it. I made a little mistake. It should be 296. And the calculator process was successfully terminated. In this lecture, we'll be going over local and remote execution methods. First, I'll show a couple simple local methods for execution. Let's say you want to run calculator through the command prompt. Well, you could just type calc as the executable is in the system variable's path for your Windows system, or you could type start calc, which will also have the command prompt execute the specified program. Then another option is to type the full path, which is useful if you didn't have the system variable path set up or weren't in the current directory. Now let's do this with a text file. I'll head over to the Documents folder and check to see I have a text document called flag. So let's start flag.txt. Or instead, let's do the full path for flag.txt. And because we're in the current directory, we could just type flag.txt to get it to run. Alright, let's say you copied over a malicious file to a remote system and you wanted to execute it. Well, I'll show you a couple of ways to do that. First, I'll show you how to do it through Wimic. Do wimic/node and the IP address of your target system, which in my case is the 132 target. I'll do a process called create to start a new process. And I'll target the calc.exe, which for this demo purpose, I'll assume is a malicious file I uploaded. Alright, let's run this. Calc.exe opened up and is running under Peter Pan, a different user that we are currently not logged in as, so that's why we didn't see it pop up on the screen, because it is running in the background. Let's delete it. Next, I'll show you how to do it by creating a service. Let's type sc. And based on the description, sc is a command line program for communicating with the Service Control Manager and services. We'll do sc and we'll remotely target the 132 host. and we'll create a service named test. Let's set the bin path for the file it will run, which I will again target the calculator executable under Windows System 32. The service was created, so we should be able to start it. But first, let's check to make sure that the service is there by doing a query of the service named test. It looks like it is there, and it's currently not running. So let's start the service. Looking over on the Win32 target, Win32calc.exe is now running, and take note that it's running as system. As a Red Team member, it is important because if you want a payload to be running as system, or as a user you currently are, you'll want to know for SC or WMIC which will give you what privilege level. Also to note, just in case you want to run a payload with this, it might be more stable to run a service executable payload. Let's delete this. Let's delete the service. See, it is successfully deleted. To confirm it's gone, we'll do a query. And then next, we'll do a schedule tasks to show an alternative way to remotely execute a file. So I'll run the following command to create a brand new scheduled task with a parameter s for the remote target, and I'll set it to the Win32 target. I'll call the scheduled task test. I'll set the schedule to once, and we'll make up a date from the past so that it won't run automatically. Let's set the RU to system, and the task it will run will be to run the calculator executable under Windows System 32. Now let's query the scheduled task to make sure it is there. It seems to be there and ready, and the next runtime is NA, because we don't have a date set in the future for it to run. Let's run the scheduled task now manually. Use the parameter run and the name of the scheduled task test. And right here, Win32calc.exe is running under system because we set the RU to system. Now let's delete our scheduled task. And it's successfully deleted. So take a look at the MITRE ATT&CK framework and notice under the impact tactic, there are 13 examples for techniques. Looking down at the 13th technique, it looks like we have a system shutdown reboot technique. Let's dive deeper. It looks like this is a technique used by adversaries to interrupt access to or aid in the destruction of systems, and it could even be done to a remote computer. Seems pretty straightforward. It shows the platforms we can do this technique against, which is pretty much any Linux, Windows, or Mac OS, and also the type of permissions, which is administrator, system, user, or root. Out of the CIA triad, confidentiality, integrity, and availability, it seems to specifically target availability, which, again, pretty straightforward. If you shut off someone's computer, that pretty much messes with the user's availability to use it. And here are some procedure examples. some examples that real-life adversaries have gone about doing this shutdown or reboot technique. Like with APT-37 wipes the target's MBR, then does the command shutdown/R/T1 to reboot the system. So how about let's do a demo to get some hands-on with shutdown and reboot commands, and let's also throw in some logoff commands as well. Okay, the first thing I want to go over are a couple shutdown commands. And first thing we'll do is run the command locally with the command shutdown. So first we'll do shutdown with a /?mark to see what options we have. Right away we see a parameter /f for the force command. We'll see /t to set the time before the shutdown happens, a /m to specify the target computer if we want to do a remote shutdown, and a /r to initiate a reboot instead of a shutdown. So now I'll run the shutdown command locally with the command shutdown/f to force it. Now it seems to come back almost instantly, but that's sort of just a thing that's happening with this virtual machine I'm running on. So let me just log in really quick. And let's go over a system reboot or restart command. We'll do a shutdown /r for reboot. We'll set the /t to 0 so it happens instantaneously, and with a /f to force it. And let's see what happens when we do this. The virtual machine is coming up with restarting, which shows it's rebooting the system, and it's taking a bit longer for it to come back since it's going through the process of a normal restart. But the previous one on a normal system will have just shut down the system completely with it not coming back up. So now logging back in again, what I'll do this time is show a remote reboot. So let's say you want to restart another computer that's on the network, which you currently aren't on. The first thing as always is you want to make sure that you have the right credentials to be able to control the other computer. And then the second requirement is to make sure you have the correct IP of the target computer that you want to reboot. So I'll just run ipconfig on both systems. And then basically the idea is from the 132 system I'm currently on, I want to target the 131 system with a shutdown reboot command. So to do that, think about the previous command we ran, except this time we'll add the parameter /m so that way we could target the remote system with the IP of that target, 131. And then run the command, and then see on the right side of the screen the other target is now restarting. Next, let's go over a way to remotely log off a user on another system. To do this effect, I'll use the QWinsta-RWinsta combo to both remotely see user sessions and then log off the specified user session. So first, to get the user sessions, we'll use QWinsta with the parameter /server and then the specified IP address, in my case .131. And it looks like the user peter.pan is logged into the system with session ID 1. So let's target this user by the session ID 1 with rwinsta, and we'll use rwinsta /server parameter with a specified target IP address, and the session ID, in our case the number 1, to remotely log off peter.pan on that remote target. And then when you run it, it looks like peter.pan was logged off, so I'll log back on. And also I'll just make a note that based on some Windows systems and versions I've been dealing with, QWinsta and rWinsta aren't always available, so you may always have to do some alternatives whenever possible. Alright, let's look at another example to remotely reboot a system without the shutdown command. And for this example, I'll use Wimic to remotely restart a system. Now the way we're going to be doing this with Wimic, which is short for Windows Management Instrumentation Command, which is by first getting some basic information from the target system. And the basic information we want is the build number, which we could get by the Wimic command with a parameter /node to target the system 131, and then OS get build number. And it looks like the build number is 14393. Now let's target the system 131 with Wimic and remotely reboot it based on the fact it has the build number 14393. So to do this, we'll do the Wimic with a /node and the target IP address, and then OS where build number equals 14393 and call a reboot. Basically saying, alright, if the target IP 192.168.122.131 system has a build number 14393, we'll make a restart. And looking over on the right side, it is restarting the system. And if you don't believe me, try it with a different build number. So we'll just put a random build number in there and try this command again. Yep, looks like it's just timing out. And we see no instances available, so basically Wimic is coming back saying, hey, there's no build number 113245, so yeah, I'm not doing anything. Alright, now we have two examples to do a remote restart, but what about a third example? And to do this third example, we'll use schedule tasks, which will create a schedule task on the remote system that will make the system restart itself. But let's also get creative now with our shutdowns. And let's do a rolling reboot, so that way every time the system starts up, it'll reboot itself again. So this schedule task command will use the parameter /s to target the remote system IP address .131. We'll do a /create because we're creating a schedule task on that system. /tn to name it test. /tr for the command we'll run, which is, well, we'll open a command.exe command prompt with a /c. So I'll run command.exe and close itself. And then the shutdown command with /r for reboot, /t0 so it happens instantaneously, and /f to force it. The /sc parameter on start, so we make sure that the scheduled task runs on a system startup, a /ru system, so the command is ran at the system permission level. After running the command, we should be able to check if the scheduled task is there on the system. Let me just go on the other system now, and then I'll run scheduled task with a /query to see if that scheduled task named test is currently there and ready. So because the schedule task is on start, the actual schedule task will not run the command unless the target system is booting up. But to get this effect going, we can manually run the schedule tasks command with a /run parameter. Alright, so let's run the command. And let's wait for the system to fully reboot to see if the scheduled task will naturally take effect on itself. Alright, so while the system is rebooting, I'm going to prep to delete the schedule task because when you have an effect in place during your red team assessments, you always want to make sure that your effect has a way to be removed. In fact, always make sure to prep and test your effects beforehand and that there is a clean way to remove the effect. Otherwise, you might not have a happy customer. And also, you might want to have an intermediary for certain or all effects. For example, like this one, you might want to have a white cell, for example, know about it. Because, for example, if the only easy way to remove the effect is by ensuring that the system is still connected to the network, you might not want the person on that target computer to disconnect the system from the network. So now that we've seen the system reboot a few times and we know it works, I'll just remove the scheduled task from the target system now. So I'll run the command and wait for the system to boot up enough for it to be connected to the network. And then it looks like the scheduled task was deleted successfully, but it looks like we have to wait for one more restart. Alright, now it looks like the system is not restarting anymore, so we could assume the scheduled task is now deleted. But of course, if you are unsure, and you know it's always good to clear your effects fully and make sure it's fully cleared, you could always do a query remotely. But next I'll show another alternative for a remote restart, which could also be a way to remotely log off and shut down a system. And that's through GWMI, which we'll do through PowerShell. And GWMI is just shorthand for Get WMI Object. And the command we'll write out is GWMI Win32 operating system, the computer name, which will be the target IP address, and then Win32 shutdown with a parameter 0. Now I mentioned just a second ago that this is a way to do either a reboot, a shutdown, or a log off. Because if you notice where I put 0, you have an option of a few other numbers to do different effects. And right here is a list of those effects, 0 being log off user, 1 being shutdown, 4 for forcing the log off of a user, 5 for a forced shutdown, and then a few other examples such as 6 for forced reboot, 8 for power off, and 12 for forced power off. But in the example I'll be running, I'll just log off the user. And looks like the command didn't work, so I'll just fix it really quick. I think it's the missing parentheses. And we'll run the command again. And maybe with a little patience, it will finally run and log off the user. Okay, let's log back in and I'll show one more example, and we'll be getting a little more creative with this one because we'll do a little bit of simple PowerShell scripting. So instead I'll write this out in Notepad to make it easier to see. I'll start with a while loop, so while true, so it will always run. And let's copy in the previous command we ran for a log off. So that way hopefully we could, on a loop, constantly log off the user on the target system. But we don't want it to run hundreds of times a second, so I'll do a sleep for 20, so that way it runs every 20 seconds. Okay, so let's paste it in and run the command. and we'll wait a few seconds before it takes effect. So it looks like it logged off the target system's user, and then we can log back in, and then hopefully within that 20-second time frame it'll log off the user peter.pan again. So just wait a few more seconds. And there we go. Looks like we are signed out again. But this time I won't log in, just to show what it looks like on the attacker's end when the user isn't logged on. And right there you see it comes up as a generic failure. So basically, because no users logged in, it failed to log the user off. So I hope you learned a thing or two about some ways to do some shutdown, log off, or reboot effects. And I'd say the biggest thing or takeaway that I wanted everyone to get away from this video is that when you're doing a red team assessment, make sure you have multiple ways to do the same effect. In this lecture, I'll be showing you how to do lateral movement with WMIC, or Windows Management Instrumentation command. So I'll be going into a session that I created from before, which I see session 1 is active. So I'll use the parameter I and 1 to go into that specific session. Then I'll run getUID as a second way to see who I am other than under information in sessions details. In a shell, I'll check first to see if Peter Pan is a domain admin, because access to the remote target will be required. It looks like Peter Pan is a domain admin, as shown from the net user command I ran. Then I'll check my IP address to confirm I'm on the 131 host, which I also know from before there is a 132 host which we will be targeting. I'll confirm the 132 host is up by ping with the parameter n and 1 to limit the amount of pings to 1. I get a reply, so I'll confirm I have access with the domain admin account by using the directory listing command to remotely access the C drive of the 132 host. It looks like I have access to the 132 host and can see the listing of the C root. Next, copy over a payload, which I have test.exe still under the downloads folder of the 131 host. You can use this copy command to copy test.exe over to the remote target. It says it copied successfully, but we can also double confirm with the remote directory listing. It looks like test.exe is in fact on that target now. Now that we have the malicious executable over on the target system, we can execute it with the following WMIC command. WMIC with node to target the specific 132 IP, and process call create to remotely open a process from the executable at the 132 host's C test.exe. It shows the process ID 2980 was created on the 132 target. A new session also popped up. Sessions to check the sessions we now have, then sessions-I and 2 to go into the new session we just created. Then we can run PS to check processes on the 132 target. And here we have the test.exe process with the process ID 2980 with the user Peter Pan associated with it. Then scrolling up and checking the previous Wimic command, we confirm 2980 is the process that was created. The lateral movement has now been complete. In this video, I'll do a quick demo to show you how to do manual lateral movement with scheduled tasks. Right now, we are Peter Pan, which is a domain admin, and the current directory we are in right now has the test.exe reverse shell payload we created to get a session on the current host. We could copy this payload to the target computer that we want to lateral over to, so let's open a command shell on the system. Then we'll copy over the test executable to the 132 host with the following command. And for this demo, let's just put it right on the root of the C drive. Let's check the remote host C drive to see if it is copied over properly. Looks like it copied over properly, so now I'll use scheduled tasks to execute it. So with the following scheduled tasks command, /create to create a new scheduled task, and parameter S to target the remote 132 system. Then parameter TN to name the task test, and I'll set the schedule to only once, and a date sometime in the past, so it won't run ever in the future unless I specifically tell it to run. We'll use RU system to have the payload run as system. And let's set the path to test.exe on the C drive. Now we'll run the scheduled task to execute the payload with the following command, using the run parameter. And it looks like a session 9 popped up, which should be a system level session. It may take a second for the staged payload to download the main payload, which a stageless payload would be faster but a larger file size. And with a little more patience, there you go. Open a shell, type who am I, and right there, you could see we are NT Authority system. Okay everyone, I'll do a demo going over how to do lateral movement with the SCM or Service Control Manager, where we'll be creating a service remotely and then running this service remotely to execute our payload. Now you might be wondering why I have psexec up right now. Well, if you ever used Metasploit before, you've probably ran into this psexec module and probably have used it. If you have domain admin credentials, whether with clear text password or password hash, this could be a simple way to get a session running on a remote target. Now, depending on what C2 framework you use, you'll probably have a psexec lateral movement option, and you might be wondering how it works. Well, the typical psexec module on these C2 frameworks most likely do it in a similar manner. For example, first, It will create a randomly named service executable like so. Then it will copy it over to the admin share of the remote target, which is a C Windows folder. Then create a randomly named service on that remote target, and have the service execute that payload on the remote target, starting a new run-dll32 process, allocating memory inside the process, and copying shellcode into it, then executing the shellcode, and then delete the file and service afterwards. This is similar to the basic functionality of how psexec from sysinternals works, as that one connects to the admin share, copies over psexec svc.exe, and uses SEM to create and start a service named psexec svc. Then run psexec svc.exe on that target to issue the command desired. So first, to replicate this, I'll need to create a service executable because a normal payload will probably not be stable when you run it as a service. So let's do MSF Venom. Look at the help options. And let's look under Format. Check what types of formats there are for the file types we'll use. Let's scroll up a little, and right here you can see exe service. So just like before, we created an exe with MSF Venom. I'll do the same except create a service executable instead. Let me check my multi-handler to see which payload it's using currently. And now let's create our service executable payload. I'll set the L host to the same as the handler. The L port to the same as well, which was 4444. I'll set the file type to exe service, and we'll name it testservice.exe. Now that we have the service executable created, let's upload it to our current target. We'll just use the Metasploit upload function to simplify things. Let's check that it's uploaded properly. Now let's copy it over to the remote target. As mentioned before, psexec normally does the admin share, which is just C Windows, but we'll just put it on the C drive. Let's confirm it's there. And looks like it copied over properly. Now let's create a service on the remote target that we want to lateral to. And we'll set the bin path to the following. Now let's run the service remotely so that it will execute the executable file test service so that we could get a new session. Looks like a session popped up. Let's check it out. Taking a look here, we are now system. And that's because services are ran at the system level. In this video, I'll go over an example of how to do persistence through adding a registry key to run a payload on user logon. Checking out current Metasploit sessions, I already have a session set up for the target 132 system, and it's running from a payload I have stored on the C root. So if we want to create a registry key that'll execute that same payload for persistence, Let's first take a look at the registry editor. First, in case you want to target a specific user, you could check under HKey users and you'll see a list of SIDs or security identifiers. Each user account is associated with a security identifier. You can find the current user SID by typing whoami/user. Here's the SID for Jason Bourne. And now we know that this SID in the registry editor is for Jason Bourne. So let's browse through, going under Software, Microsoft, Windows, Current Version, Run. And it looks like for me, I have a registry key for OneDrive which is linked to a file under the data column that will run when Jason Bourne logs in. For the example I'll use, I'll set the registry key in a place that will target any user logging in under HKey local machine, Software, Microsoft, Windows, Current Version, Run. Now let's add a registry key that will execute test.exe whenever a user logs in. To do that through an active Metasploit session, I'll go into the session currently open and open up a shell. Now to create this persistence, I'll use the registry add command, setting the path to where I browse to on registry editor. I'll set the name to test, but you can call it something else. Then I'll set the file to test.exe for it to run, and we'll force this. I like to use /f to force the registry add command, because if there's already a registry key with the same name in there, it'll ask a question if you're sure you want to overwrite the registry key. And because this shell session has interactivity issues, it may break. So let's see if the registry key was created by refreshing the registry editor. It looks like the registry key test was created with a data field pointed to the malicious test executable. Now let's log off and log back on to see if the persistence effect was successful or not. It looks like I lost my session, but hopefully when a user logs in, our persistence will kick in and a new session will pop up. Great. It looks like a new session was established. Now you can see that the user is Jason Bourne. And we can double check the user with a getuid command. Now let's log into another user to see the effect take place on another account as well. So I'll try logging in as Jane Doe. It looks like a new session came up. The new session is now for Jane Doe. For this video, I'll be going over persistence through scheduled tasks. I'll be doing this directly on a Windows machine in case you wanted to follow along if you didn't have Kali Linux or Metasploit. First, I'll do whoami/groups, so I can make sure that my current user is in the domain admins group. So since it looks like this user is in the domain admins group, we can take a closer look at scheduled tasks with a /?. Scheduled tasks enables an administrator to create, delete, query, change, run, and end scheduled tasks on a local or remote system. For this persistence effect, I'll use a /create to create a scheduled task in the background to enable the persistence. So I'll type in the command scheduled tasks /create /? to get more information on the /create parameter. Looking at that /create, we have multiple extra parameters we could throw in. Notice the parameter sc for schedule, mo for modifier, and then /tn for task name, and /tr for task run. Scrolling further down, you can find more information on each of these parameters. For example, looking specifically at /tn and /tr, we can find more information and even an example. So let's combine these parameters to have scheduled tasks run and execute the calculator program on the computer every 10 minutes. Let's have the assumption that calc.exe is a payload we uploaded on the system that will give us a new session every time it runs. So we'll run the command schedule tasks /create /tn for the name of the scheduled task, /tr for the command we'll run, which will run calc.exe directly, and then /sc to schedule it every minute, and to /mo modifier to run specifically every 10 minutes. Now that the scheduled task is created, we could always check to confirm that the scheduled task is there with a query parameter. Let's run /query /? to get more information on this command. Query enables an administrator to display the scheduled tasks. Notice the /tn for task name, and remember the task name we used from before, which was named calc. So let's type the command scheduled tasks /query /tn calc. Looking under time, we could see the next time that it's scheduled to run is at 10:29 p.m. If I look at my clock, it seems to be quite a while until the time comes for the effect to run. So I'll go to my clock and change the time myself. Now all we have to do is wait a few more seconds. And then at exactly 10:29, it looks like calc pops up. So in this lecture, I'll be doing persistence by creating a service that will run a payload on a Windows host every time the host is booting up from starting or restarting, getting a system level session. Right now, I have a session popped up on the target 132 host, which I obtained from this test.exe payload that I have in the C root. So I'll create a service that will run that payload every time the system boots up. If you watched the service lateral movement video, you'll see that we had to create an exe service because it was a more stable way for a payload to be started by the service. But for this demo, I'll show another way to run this payload, specifically the malicious executable file named test, that I have uploaded on the C root. To do that, let's go into the shell. Now let's create the service. For testing purposes, I'll call it test, but then for bin path, I'll do something different. Notice that I type command.exe/k, which if you look over here on the right side, I'll do cmd/?mark to get more information about the k parameter. It says that the k parameter carries out the command specified by string, but remains. So let's set the path to the malicious executable file, and also for persistence, let's set start equals auto, so it'll run every time the computer starts up. Now that the service is created, we could always check more information on the service with scqc to query the configuration information, or sequery to see the status of the service. I'll restart the system to see if the effect takes place. We lost the session, but hopefully we'll get a new one when it reboots. It looks like we got a new session, and it looks like it's at the system level. I'll just go into the session to confirm again it is system. In this lecture, we'll be going over how to do persistence through a WMI event subscription. But first, we'll go over a lesson of WMI and how you would view current subscriptions on your computer. WMI stands for Windows Management Instrumentation. Microsoft implemented WMI for the use of accessing management information in a Windows Enterprise environment. Management through WMI can be done both locally or remotely through a written WMI script or an application to automate the administrative tasks. There is a wide array of management actions that are possible from WMI, ranging from the configuration of security settings to execution of processes. Now in comes permanent WMI event subscriptions. These are persistent objects that last until removed from the WMI repository, which are capable of monitoring and triggering off a wide variety of events. These WMI event subscriptions can be set up through a PowerShell or MOF file that you create. The event subscription is made up of three parts: the filter, which will narrow down the type of event you want to trigger on; the consumer, which is the action; and the binding, which combines both the filter and the consumer. Just take note that you have to be administrator to create WMI event subscriptions. The filter for WMI event subscriptions narrows down the specific event and delivers it to the consumer, so the consumer executes an action. The filter can trigger off specific events such as a processor being created or deleted, or even a change in the system's time. The consumer is the action that takes place after the triggered event. You have a range of consumer classes you can choose for the action, such as a command line event consumer for command line based actions, to the SMTP event consumers, which sends email based on an event. The binding just binds both the filter and consumer, so the filter sends notifications to the consumer you choose. Alright, next we'll go over how to look at the current filters, consumers, and bindings on the system. Then we'll create a permanent WMI event subscription that will trigger a payload off an event by writing a MOF file, then running it. Okay, let's take a look at the current WMI event subscriptions. First, we'll look at the namespaces that are available. We have the option of doing it in WYMIC, or we have the option to do it in PowerShell. Here are all the namespaces available on your system. Let's take a look at the classes available in subscription. We'll type GWMI namespace and we'll look under root subscription. Great, let's take a look at some of these classes. Couple interesting ones to note is this one, event filter. All these consumer classes are available, and also filter to consumer binding. If we want to take a look at the current event filters on the system, we can always type GWMI namespace, look under root subscription, or other namespaces if you're curious as well. Name class, and specifically event filter. It looks like there's only one event filter currently on the system. And it looks like it triggers off of any Microsoft SCM event log event. We can look at event consumers by typing GWMI namespace, again under root subscription, class, and we'll look at event consumer. So we have one again. Its name is SCM event log consumer. Now let's list the bindings. Let's just type get WMI object, namespace, look under root subscription again, and we'll target filter to consumer binding. So again, there's one listed, and you can see the binding it has between the filter and the consumer. Okay, let's go over the creation of a MOF file. We'll call it test.mof, and we'll open it up in Notepad. Okay, so a MOF file is a managed object file, and we'll use it as a way to create new event filters, consumers, and bindings. For this first example, we'll create a permanent event subscription that will execute test.exe in the root of the C drive. And hopefully when this executes, we'll get a new session. For this first example, what we'll filter on will be every time the process calc.exe is killed. So first, we'll set the namespace to root subscription. And you'll see I added a few more backslashes because I have to escape it for a MOF file. Next, we'll create the consumer. I'll name it test consumer. And what I'll do is I'll use this command line event consumer to execute test.exe. And now I'll create the filter. I'll call it test filter. I'll set a query. To filter off a specific consumer. Let's take a look at the classes available under root subscription. Let's use instance deletion event, so whenever a process is killed, the filter will send a notification to the consumer. Do this within 5 seconds. Set target instance is a Win32 process. And we'll set target instance name as calc.exe. So let's check what the process name is. Looks like the name of the process is Win32 calc.exe. Set the event namespace to subscription. And last, we'll create the binding. So we want to bind the filter with a consumer. And that should do it. Let's try this out. Save it. Check that's there. And we can run a moff file by typing moffcomp and then the file name test.moff. Looks like I have an issue, so I'll fix it really quick. It was just a little typo. We'll resave and we'll try again. Looks like it was successful. Now let's close calc.exe to see if we get a session. Awesome. Let's go into the session. And there you go. Looks like we are system. Let's check to see what the filter looks like on the system. So we have test filter here, and we could see what it queries on, which is whenever there's a deletion event of a Win32 process and the process name is win32calc.exe. Let's look at the consumer now. So we have our test consumer here, and it executes test.exe. Let's do one more WMI event subscription example, except instead of triggering on win32calc.exe being killed, we'll trigger off of a modification of the local time on the host. To do this, instead of instance deletion event, we'll do instance modification event. And instead of win32 process, we'll go off of local time. For the time, we could go off of the year to the month, to the day, to the hour, to the minute, and to the second. For this example, I'll show it by the hour, to the minute, to the second. Let's do it the next 3 minutes after where we currently are. We'll say an OR, so we can have multiple minutes to choose from. And we'll finish it with an AND target instance second equals 30. So it'll trigger on the 30-second mark of one of these minutes in the hour, which it's 1 a.m. right now. And for this, I'll set it to the namespace CIMV2 because the subscription version of instance modification event has been a little buggy for me. We'll save it and let's run it. And you can see the reason it didn't work is because I had a typo. So let's set it to the next minute. Recompile it and try again. and it should execute in a few seconds. And there you go. Let's go into the session. And look, we are NT Authority system. In case you want to delete the WMI event subscription, here's a way to do that. First, let's query the filter and see what the name is. We could see the event filter we created, and the name of it is test filter. There is an option to delete WMI event subscriptions with PowerShell. But for this demo, we'll use Wimic instead. With this Wimic command, we are targeting the namespace root subscription, the path event filter, and deleting the filter where name is test filter. Let's run the command, and it says it's successful, but let's query the filters again to see if it's still there. Alright, looks like it's not there anymore. Next, let's delete the consumer. First, let's query all the consumers to see what the name of our consumer is. And it looks like it's test consumer. Now let's run our Wimic command to delete the consumer. For the Wimic command, we'll target the root subscription namespace and delete the consumer where the name equals test consumer. Now after running this command, let's check to see if the consumer is still there. Looks like the consumer is gone now. Now finally, let's delete the binding. First, we'll query the bindings to check to see if it is there. Next, we'll run this Wimic command to delete the binding in root subscription under filter to consumer binding, where the filter is equal to test filter. Let's check to confirm that it is gone. And looks like it's gone. Now we have deleted the WMI event subscription that we put in place. Alright, let's go over golden tickets. In a Windows domain, a golden ticket is pretty much the keys to the kingdom. It is a self-generated ticket with domain admin rights on the network. The golden ticket can be seen as a form of persistence because for some reason you ever lose access to a domain admin account, you can always use a golden ticket to get access again on the domain. We'll go over a demo of how to use Mimikatz to get the information so you can create your own golden ticket. There are 4 components you'll need for creating a golden ticket: the user account you want to create the ticket for, the domain SID, and the KERB-TGT hash. So let's check our current sessions we have, and right now I have a domain admin session and a domain user session. But to get the KERB-TGT hash, I'll need to have a domain admin account. So let's look into that right now. So for the KERB-TGT hash, I'll use Mimikatz. Let's look for Mimikatz. And this looks like a good one right here. So let's save that path, and then we'll go back into the session and upload it. Alright, let's go into a shell. Go into Mimikatz, and to get the KERB-TGT hash, I'll use LSA dump. And looking at the LSA dump modules, we'll use DC sync to help with obtaining the KRB-TGT hash. So right away, we could see some interesting information we should hold on to. For example, the domain name and the name of the domain controller. Here's the NTLM hash of the KRB-TGT. And here's the domain SID. We can ignore the last number. For the user, you could use any user account, but I would recommend using a domain admin account to replicate. So let's look at the domain admin accounts on the network. So here's a couple of domain admins we could impersonate. Let's use Jason Bourne. Now that we have all the information we need to create a golden ticket, let's create it with Mimikatz. But currently I'm in the domain admin account, so already I do have access to the domain controller. So there's no use for me to create a golden ticket for this demo on this account. But that's why I also have a domain user session. So let's go into the domain user session. Let's upload Mimikatz, drop into a shell, and let's just confirm we are a domain user with the limited privileges. As you can see, he is a domain user, but not a domain admin. And also let's confirm we cannot access the domain controller. Access is denied. So let's create the golden ticket. So we'll use this command in Mimikatz, which you can see a list of Kerberos modules to use in Mimikatz right here. So we'll set the domain to fun.com and the SID right here. The hash for the KRB-TGT, and the user account jason.bourne. Looks good. Looks like the golden ticket was successfully created. Let's confirm it was created by listing it out. Now let's test to see if we have access to the domain controller. And it looks like we have access to the domain controller as a domain user. For this section, we'll be going over some basics of evasion, what it is, an example of how a blue teamer could spot malicious activity, and a few videos that show some quick demos like how a red teamer could minimize their tracks from getting caught. When a red teamer is doing anything on a target network, it is in the red team's best interest to do it while remaining undetected. Because in the end, it comes to a cat and mouse game where blue team is looking for your presence on the network and trying to kill your connection one way or another. Two of the most common ways a blue teamer might catch and stop you are either by terminating the connection to your IP address or stopping your process and or deleting your payload. This is of course assuming they just want to get rid of you instead of taking a step back and watching what you are doing every step of the way. That way they can learn what your objective is. Now, there are ways to mitigate these actions as a red teamer, depending on how advanced and skilled you are, but also some C2 post-exploitation frameworks have added features to help in this arena as well. When it comes to mitigation, your mindset as a red teamer must be in the realm where you are asking questions like, how do I blend into my target network? What looks normal? What security defenses are implemented on the network? Like maybe an IDS or IPS, a firewall, any host-based loggers, or an antivirus, or anything else. The more you understand your target environment, the better the chance of you blending in. Think of it this way. If you cashed out $1 million from your bank account right now and you're in a ghetto part of town, would you walk out with a business suit with the money in a nice briefcase? Or would you wear something that blends into your environment? Like maybe put the cash in a worn out backpack and walk normally through the crowd. It is this type of awareness of knowing your target network that's important. You might be wondering, what are some options for you to do evasion on the target environment? It may require some knowledge of your environment you're going up against. Well, the first method is pretty straightforward: to disable any security defenses you run into. This would sort of be like that spy movie approach of shooting down cameras, although it is very effective at preventing your tactic from being stopped by anything automated. It could be a major red flag for any active security defender on the network if they notice their defense is going down. This is probably not the best approach if you want to stay under the radar and you don't want your target to know you were ever even there. The next option is to blend into your environment, sort of like walking into the person's territory undetected by wearing the same clothes or uniform and maybe a fake badge that seems right. For the target network, you could potentially do this by doing things like making your HTTP, HTTPS, or any other protocol's traffic for that matter very similar to the rest of the traffic going on. Maybe using names for things like processes, executables, and such that blend in with the rest, changing timestamps of files uploaded to others around it, or maybe even stealing and using the session of the person already logged into the target. Last example is by using unwatched areas. This requires you to know way more about the security defenses you are going up against. Sort of like if you know a security guard's daily patrol path and knew the areas he never checks. For example, maybe there's a host-based logger that you grab the configuration files for and find what areas it targets and which areas it ignores. You may ask yourself the question, is there any exclusion? A simple example is the antivirus could have an added exclusion for a folder which won't ever flag for any virus put in the folder. So as a red teamer, you successfully find a way to blend into your target environment, accomplish your tasks, and decide it's time to leave. But since there's logs left behind, whether suspicious looking activity or normal, it is probably best to clear those tracks. You may want to check for any Windows logs on the system you are on. Also check if there's any remote server that's collecting logs. Check if you can access the log server, and if so, can you clear specific logs off it? What about any security tools installed on the system? Are there any additional logs from these tools being stored somewhere for the security defenders to view later? Also be concerned about any potential log that could be created when you close a session to a system. When conducting any red team operations, it is vital to ensure you make note of every artifact you put on the target system. These include any scripts, executables, or any files you staged in another directory, whether compressed or not. Now, if you are a defender and trying to find malicious activity, you might find yourself looking through many logs if you're trying to pin down where the red teamer might be. Although, depending on which logs to narrow down on can really depend on how advanced your opponent is. For example, a beginner level adversary might depend on automated tools to do their tactics and might not even be concerned as much about evasion. You could probably just take a step back and let your security measures do most of the work, or alarm you where the red teamer is. On the other hand, the more advanced the red teamer is, the more effort and thinking you might have to put into figuring out what's going on. For example, maybe you find a point where the attacker was, and are trying to follow the tracks to figure out what the attacker did and where the attacker currently is on the network. Maybe you will be thrown off when trying to follow obvious tracks that the attacker placed on purpose to try to throw you off. Whatever the case is, it is vitally important for someone in cybersecurity to understand general red team tactics and how they work, to understand how they can take apart what's going on in their network. Let's use the antivirus on your computer as an example. Sure, if you keep it up to date, it'll catch most, if not all, the latest automated payloads and viruses out there. But if an adversary targeting you spent more time on his craft, he could easily obfuscate his payload to bypass any antivirus. And in this case, if you depend on automated antivirus scanners waiting for a flag to come up for malicious activity, you'd be doomed against any more advanced adversary. By having knowledge of how a payload works, or any malware for that matter, you could manually find that suspicious activity on your computer or network and eradicate that issue. So, in the end, it really depends on your skill as a defender or attacker on how well you can either catch or evade on the target network. So, I'm going to be going over a demo of how you could use a potential tool a blue teamer could use, such as Sysmon, to detect a basic automated lateral movement from a C2 post-exploitation framework. Sysmon is a pretty popular system monitoring tool as part of Windows sysinternal suite, created in 1996. It provides capabilities of monitoring and logging system activity of things such as process creations, network connections, file creation times, and much more. If you want to follow along in this demo, just download the sysinternal suite from Microsoft and then get a configuration file. I would just recommend getting the most popular Sysmon configuration file from Cybersecurity, which you can download on GitHub. Now just keep in mind before this demo that there are so many ways to go down this evasion rabbit hole, and it just gets exponentially more advanced along the way. Let's just keep in mind this is a beginner's course and go from there. Okay, so if you want to just follow along, I'm going to install Sysmon really quick. We'll need to have an administrator command prompt to be able to do this. So open one up, and let's take a look in this folder. I have an XML file that's a Sysmon configuration file from Cybersecurity's GitHub page, and we'll use sysmon64.exe if you're installing Sysmon on a 64-bit operating system. I'll change directory to the Sysmon folder, and I'll run sysmon64. I'll accept the EULA right now in command prompt so I don't have to click yes on any EULA pop-up. And then I'll type taci to set the configuration file I want to use during the installation. And after installing Sysmon, I can open up the event viewer. Under Applications and Services, Microsoft, Windows, and scroll down to Sysmon. And then check Operational, and you'll see the current events that it has logged so far. So we can just clear the logs by clicking Clear Log on the right side panel. Let's clear the logs, and I'll run a lateral movement from a popular C2 post-exploitation framework, and let's see if we can catch the activity and determine what type of lateral movement I did. So I just ran a lateral movement from a popular C2 post-exploitation framework, and you can either press F5 or click refresh on the right side panel to show the latest logs captured. It looks like here we have the activity that was logged by Sysmon for the lateral movement. we can see multiple events being logged along the way, such as file creation, registry values set, processes being created, terminated, and so on. If we click on the file create event that took place, it looks like an executable with a random file name C9300-9b.exe, which was created on C Windows. Next, it looks like we have two registry values set, and clicking on one, it seems like Windows services.exe is doing something with starting the executable. Under the process create event, notice services.exe as the parent process, and scroll up to notice it is executing the random executable C9300-9b.exe. The next process create, we can see the random executable is now the parent process. Scroll up and notice the random executable started up rundll32.exe. Next, it looks like the random executable's process was terminated. There was a DNS query from the process rundll32.exe. Then, it looks like there's one more registry value set that has to do with services.exe. Just for your knowledge and awareness, the D word that's set as 4 is what happens when you do a service deletion with a service control manager. Finally, let's look at the network connection and take note that rundll32.exe is being run as system and its destination IP is .130, which is the attacker IP the payload is calling back to on port 80. So just to quickly review some of these logs, we can see some pretty sketchy things going on, from down to even a random exe being created in C Windows or the admin share. And looking at all the steps of a random file being created on the system, being ran from Windows services, then spawning another process and deleting itself is pretty much as I said before with how automated PSExec laterals typically work on some C2 frameworks. Now this doesn't mean don't use the C2 post-exploitation framework, it just means that you need to be aware of this before doing your red teaming. Maybe you are facing a blue team that's not up to skill and needs the training, so you don't mind giving yourself away. Or maybe you want to start off easy, then progressively get harder for the blue team, or the other way around. Either the case, this specific C2 post-exploitation framework I used for this automated lateral does have the option for you to create your own customized versions of TTPs. So you wouldn't have this issue if you spent some time developing the lateral movement yourself. Now, we previously went over an example of how a blue teamer could use a host activity logger, such as syspawn, to see a simple automated lateral movement from a C2 post-exploitation framework. But what could you as a red teamer do to fight back? Well, remember in the brief on evasion how I mentioned 3 potential ways you could think about for bypassing a security tool. That is disabling, blending in, and the unwatched areas. How about I show you a quick example for all 3 against sysmon? For any security tool you are up against, you could think of these general ways when doing red teaming. Although maybe you can use your own creativity and think of more ways as well. So let's say I just got a shell on the system. As a red teamer, you might want to check what security tools are on the system. Part of that can be to first check processes running. Looking here, we have sysmon64.exe running. Now, we could also always use various other ways such as through PowerShell, Wimic, or registry as well. But did you know a blue teamer could just rename the process for sysmon to something else? How would you find if sysmon was running? Luckily, another way is you could always check altitude numbers, which sysmon will always be 385201. Check this with FLTMC. Notice the filter name sysmon driver and the altitude number. Just be aware that a blue teamer could also rename the filter name as well, so look for that number instead. Now that we know the security tool is running, we can then see if there are any configuration files on the host. With sysmon, you could go to the executables path and use -c to get configurations. Of course, you could also always get lucky and find a configuration file on disk. You can find where sysmon's file is from the process by mimic process where name equals sysmon64.exe get executable path. With the path to sysmon's executable found, we can then execute the sysmon64.exe with the full path with a -c to get the current sysmon configuration. Now that we have the configurations, let's think of ways to bypass and/or evade sysmon. Thinking back to what I mentioned, we could also disable it, blend in, or go in the unwatched areas. With the sysmon configuration file, we could definitely play around the rules and look for those ways to blend in or find areas not logged. So let's find a way to do each of these two first. To show it in a simpler format, I'll just open this on the Windows machine in Internet Explorer. So first, let's see if we can find any unwatched areas. Let's go search for the file create event ID. Taking a look here, it is flagging on anything under the rule file create on match include, which looks like the downloads folder is under. Let's just quickly test that by creating a text file in the downloads folder. Looks like it is flagging on any file created in the downloads folder. Let's test creating a text file in desktop. It seems like it didn't flag a file creation event ID. Let's try to upload test.exe to the desktop folder. Why did it flag? Looking down further in the configuration file, it looks like it just flags on any file with extensions such as .exe, .jar, and so on. Let's rename test.exe to test.blah on the attacker Kali machine. And check it out, no flag. What if I renamed it now? I'll just run the move command, which doesn't actually create a new file, to change test.blah to test.exe. It looks like no event still. Now let's try to run it. Execute tacf test.exe. And there was a process create event ID. Basically, you get the idea. Do something similar for process creation to evade that as well. Now think of doing a lateral to another system and not flagging any sysmon event IDs while doing so. Pretty cool. Just remember about any other security tools there could be on the systems and also your network activity as well. These are all factors when it comes to evasion. Finally, we can always disable sysmon, and a simple way to do that is to unload the sysmon driver. Remember when we used FLTMC to view the altitude to determine sysmon is running? Well, FLTMC is an executable that comes with Windows which does mini filter driver management. You can load filters, unload filters, list filters, and so on. So if the name of the sysmon driver is sysmondrv, we can just type FLTMC unload sysmondrv to then cause the system to drop recording sysmon event logs, except for networking. What's great is that the system might still think that sysmon is still running just fine, yet pretty much nothing is happening. Take a look. Let's open calc.exe and look at the sysmon event log viewer, refresh, and see the process create log come up. Now let's unload the sysmon driver with FLTMC. As a blue teamer, you might want to take note of any event ID 255. Open Calc again and refresh the log viewer, and there isn't another log created. Now when it comes to red teaming, just like with evasion, it's really up to your creativity as an operator with how you go under the radar. There is a limitless amount of ways. For example, have you thought of maybe even changing the configuration file to not log what you want? Just play with your imagination, think outside the box, and keep trying things out. And as a blue teamer, you'll have to do the same thing to catch a good red teamer.